Hi, my name is Chris Hegarty. I work in the Java Platform group at Oracle, and today I'm going to be talking about handling response data with the Java 11 HTTP client. In this session, we're going to take a high-level look at the Reactive-streams interfaces in the Java Platform and how they operate. Using this knowledge, we will then see how the HTTP client leverages these interfaces to handle request and response bodies. We'll work through an example of how to write a custom response body subscriber and how to interoperate with existing flow publishers and subscribers. Before looking at reactive streams, it is useful to remind ourselves of the classic producer-consumer paradigm and some of the potential concerns and issues with it. Typically, the producer generates items or data, puts them in a queue or buffer of sorts. At the same time, the consumer consumes the data by removing items one at a time from the buffer. The problem is how to make sure that the producer is not blocked when the buffer becomes full, or that the consumer is not trying to get data when the buffer is empty, and how the notification mechanism to implement such if it happens, as well as trying to determine a reasonable buffer size. Moving to reactive streams, the producer is known as a publisher that publishes items. The consumer is known as a subscriber that receives items. The publisher has a single method subscribe that takes a subscriber. The subscriber has four methods: unsubscribe, onNext, onError, and onComplete. We'll take a look at these now. A subscriber can be subscribed to a publisher by calling the publisher's subscribe method and passing the subscriber. The publisher then calls the subscriber's unsubscribe method with a subscription. This handshake between the subscriber and the publisher results in the publisher having a reference to the subscriber, and the subscriber having the publisher's subscription that it was given in unsubscribe. It is the subscription that acts as a mechanism for the subscriber to send signals to the publisher. For example, using this subscription, the subscriber can request a number of items from the publisher. The publisher can then publish at most that number of items by calling the subscriber's onNext method n number of times, each with a single item. This request mechanism provides the subscriber with back pressure, since it is in control of the maximum number of items that may be sent to it. If the publisher has no more items to publish, then it calls the subscriber's onComplete method. This informs the subscriber that the publisher, regardless of demand for more items, will publish no more items to this subscriber. If the publisher encounters an error, say reading from a file or network, then it informs the subscriber of this by calling the subscriber's onError method with a suitable throwable indicating the problem. The Java platform provides support for reactive streams through a number of interfaces in the Java Util concurrent flow class. There is a publisher for publishing items, a subscriber for receiving items. A subscriber subscribes to the publisher and can issue requests for items as needed. The HTTP client models request body using a subtype of flow publisher, a request body publisher. The HTTP client subscribes to this publisher when sending a request that has body. On the receiving side, when a response code and headers are received, the HTTP client calls the body handler. The body handler can then inspect these values if it wishes before creating a body subscriber. This subscriber returned by the body handler will be used to receive and process the actual response body bytes. The HTTP body subscriber is a subtype of flow subscriber, and the HTTP client acts as a publisher of response body bytes. There are a number of factories for creating body publishers and body subscribers for most common use cases, like publishing request body from a string or from a file, or converting response body bytes into a string or streaming them to a file. In this session, we're going to focus on the response. Body handler is a functional interface that has a single method apply that takes a response info containing the status code and headers. The body handler is invoked when the response status code and headers are available, but before the actual response body bytes have been received. The body handler can inspect the response code and headers before returning the body subscriber. The body subscriber will then be used to receive the actual response body bytes. Body subscriber is a flow subscriber of an aggregate of byte buffers. The byte buffers contain the response body bytes. Body subscriber adds a single abstract method, getBody, that returns a completion stage that completes with the higher level type that the body subscriber implementation will convert the response body bytes into. The body subscriber class contains only static factory methods, and these methods are factories for creating body subscribers that can be used for most common use cases, like converting the response body into a byte array or string, or streaming it to a file or an input stream. Let's take a look at writing a custom body subscriber for handling response data. Okay, so let's take a look at how to write a custom body handler and body subscriber. Before doing that, let's take a look at how one of the convenience body handlers works. So here we've got a utility get method. It retrieves a given URI and returns the response body as a string. So first it creates a new HTTP client over which the request is going to be sent. Then it builds a request from the given URI. Then it calls a send async method to send a request, and it uses the body handlers of string static factory method to create a body handler that converts the response body bytes to a string. Then the completable future then apply method maps the HTTP responsive string to its body type, in our case is string, and the completable future of string is returned. So we can see example usage of this get method in the main method. So here we can see the get method is being passed a URI, and then join is being called on the completable future that's returned. This blocks execution until the string response body is available, and then the program simply prints out the body. So let's run that. So here we can see the response body string being printed out, and it's just some XML. At this point it'd be useful to see the response status code, so let's print that. So here we're using the completable future when complete method to print out the status code. Really we should be checking that the response value is non-null in case an error happens, but for simplicity we'll just print it for now. So running that again. Okay, great, we can see the response code is 200, so everything's okay, and again the response body is printed. Alright, so that's everything working using one of the convenience body handlers. Let's take a look at writing our own. So we need to implement the body subscriber interface, and in this case our type is a string. Okay, so the body subscriber has a single method called getBody, and it returns a completion stage of t. T is a string in our case, and we must also implement the 4 methods from flow subscriber. So let's take a look at them. We'll start with the getBody method. So the getBody method needs to return a completion stage of string. So let's use completable future, which is a concrete implementation of a completion stage. So we've called our completable future a body CF because it holds the response body, and we can return that from the getBody method. Now we'll move on to unsubscribe. So the HTTP client is a publisher of response body, and this string subscriber subscribes to that publisher. So first it will have its unsubscribe method invoked with the subscription from the HTTP client. So let's store that subscription. Okay, now we have a subscription. We can request some more response body from the client, or we can cancel the subscription if we're no longer interested. Let's request some more. We'll just request one. At this point we can hook up error handling. So we'll complete the body CF exceptionally if there is an error happens. In this simple implementation, we'll just accumulate all of the response data, all the byte buffers in a list, and then we'll convert the response body into a string at the end. So let's create a list. Okay, so every time response data is received, we add it to the list. Let's give that a better name. Okay, great. So we're only left with the onComplete method. So again, in this implementation, we will just determine the number of bytes we have, put them in a byte array, and then convert that byte array into a string. So once we know the number of bytes remaining in each byte buffer, we can sum that up. So that's the total number of bytes that we need in our byte array. So let's create a byte array of that size. Okay, now we can iterate over the buffers. And add them to our byte array. Oops, I call that buffers. It should be buffer. Buffer.get to the byte array. At this point we need an offset. So let's create one. It's initially 0, and we need a length. And the length is going to be the number of bytes remaining. And this is offset. We will need to increase the offset as we iterate. Okay, now we have a response body bytes in a byte array. Let's convert that to a string. For simplicity purposes, we'll just ignore char set conversion for now. Okay, great, we have our string. Let's complete the body CF with that string. Okay, at this point everything looks alright, but we forgot one thing. Because an unsubscribe, we've only requested one more callback. Every time we receive a callback, we want to request another one. So single step, one at a time. Okay, now we have our string subscriber. Let's hook it up with the HTTP client. So we need a response body handler here. Response body handler is a functional interface that takes a response info and returns a subscriber. In our case, we'll unconditionally return a string subscriber. Okay, so let's run that. Okay, great. So we have response code 200 again, and we have our response body as a string. So let's just take a look at what's happening here. Let's add a debugging statement to the onNext call. Oops. So onNext is being called with buffers, and we'll change the URI so that we get some more response data. Okay, let's run that again. Okay, we can see onNext is being called a number of times with heap byte buffers that contain the response body bytes. They all get accumulated, and then in onComplete they get converted to a string. And our string in this case is some XML with a very long line. Okay, so now we've seen how to write a custom body subscriber that converts the response body bytes into a string. What if we had a flow subscriber? So an existing flow subscriber and we wanted to use that with the HTTP clients. The HTTP client only works with body subscribers, so let's see how we can make that work. So first of all, the flow subscriber doesn't have a getBody method, and it also doesn't have a body CF. For simplicity, let's just print out the error if one were to occur. We can remove this here. So the flow subscriber still needs some way of exposing its data. So let's give it a private field, string, to hold its body, and an accessor getBody to return the body. Okay, in onComplete now, we need to set the body field. Okay, so now we are string subscriber, which is an implementation of a flow subscriber. How can we use this with the HTTP client? Well, the HTTP client provides convenient static factory methods that adapt between flow subscriber and body subscriber. So let's use one of those. So there's two variants of the from subscriber adapter. The first takes just a subscriber, and the other takes a subscriber with a finisher function. We're going to use the latter because we need to extract the data from the string subscriber and to complete the HTTP's completable future with that value. So a new string subscriber. We'll use the string subscriber getBody methods to extract the data from the flow subscriber. So instead of using a new string subscriber here, we can use the body subscriber. Okay, let's run that. Again, we can see all the onNext implications, and we have the response body as a string again. We can simplify this even further. Instead of using a body subscriber directly, the body handlers and body handler classes expose factory methods of similar names. So let's use one of those instead. Okay, so we don't need the lambda here anymore. We should be able to use the body handler directly. So let's run that to make sure it works. Okay, great, same output. So we've seen how to write a custom body handler and also how to adapt a flow subscriber to the HTTP body handler or body subscriber. There are a number of adapter methods that support interoperation between regular flow types like flow publisher and flow subscriber and their HTTP client equivalents. The one we just seen being used in a demo, from subscriber, has two variants. The first just accepts a flow subscriber and returns a body subscriber, a void. In this case, the response body is not being made available through the HTTP response, but instead through some other mechanism, like an entry in a database. The second variant supports a finisher function that will be applied after the subscriber has completed, and we've seen an example of this in the demo. There are also a similar pair of methods from line subscriber that interoperate with flow subscribers of string, where the response body data is converted to a flow of string lines and sent to the flow subscriber line by line. This is somewhat analogous to buffered reader readlines or the NIO files lines method that returns a stream of lines in a file. There are also equivalent adapters on the sending side for request body. To summarize, the HTTP client treats both request and response body as reactive streams, so gets the benefit of asynchronous programming with non-blocking backpressure. We've seen how to write a custom body subscriber implementation that behaves similar to the convenience body subscriber returned by body subscribers of string. The HTTP client provides a number of adapters for interoperating with existing Reactive-streams publishers and subscribers. You can download Java 11 now at this URL. Please join us at OpenJDK or follow us on Twitter at OpenJDK or hashtag Java 11. My own Twitter handle is @Chegar999. Oracle is the steward of Java, providing a large amount of development engineering funding for the Java SE platform and OpenJDK. Oracle provides leading-class premier support for a low cost that's easy to purchase with simple pricing tiers. Thank you for watching.